Today on Capechi's Corner, we're going to look at exponential functions. An exponential function is a function in the form of y is equal to ab to the x power. The base is constant, so it's going to be a number, and the exponent is the variable. So for instance, we have y is equal to 2 times 3 to the x power, y is equal to 5 to the x power, and y is equal to 1/3 to the x power. When looking at domain and range, remember that the domain is the x values and the range is the y values. Now we're going to use different statements to go along with the domain and range, so it's important that we understand it. When we say all real numbers, it's exactly that, all numbers that are real. So we're talking about everything on the number line, including positive numbers, negative numbers, and 0. Nothing is excluded. When we're talking about all positive real numbers, again, obviously positive numbers, but we're not including 0 or negative numbers. Last one is all negative real numbers. So we're again using all negative numbers as it states, but we're not including 0 and we're not including positive numbers when we're talking about all negative real numbers. So here are some examples. In the first example, we have a graph and its domain is all real numbers because if you can see, we have arrows on the end. So we're going to continue to go to the right and we're going to continue to go to the left. So that's including all negative numbers and 0 and positive numbers. So the domain is going to be all real numbers. If you look at the range, remember the range is my y values. And here's my y-axis right here. And it looks like here all of my values are above 0 on my y-axis. So I'm going to say that we're talking about all positive real numbers. In the second example, again, we are going from left to right. Arrows on the end here, arrows on the end here. They can continue, so domain is going to be all real numbers. This time when we look at the range, again, here's my x-axis. Everything is below the x-axis. So all my y values there are negative. We're not touching the x-axis, so my domain is going to be all negative real numbers. Again, we're not including 0 and we're not including positive values. We're now going to look at some exponential functions. We're going to graph them and then we're going to determine the domain and range. So my first one is y is equal to 3 to the x. Now again, we have a table of values. So anytime we're looking at a graph, it's a good idea to do some negative values, a 0, and some positive values. It just gives you the general shape of the graph. So when x is equal to -2, I'm going to substitute that in. So I have y is equal to 3 to the -2. Now remember our rules with negative exponents. We need to go to the other side of the dividing line, and that negative becomes positive. So my value there is 1/9. I'm going to do the same thing when x is equal to -1, and I have y is equal to 3 to the -1, which is 1/3. When x is equal to 0, I have y is equal to 3 to the 0. Anything to the 0 power is equal to 1. And then I have x is equal to +1, so I have y is equal to 3 to the 1st, which is 3. And our last one, we have x is equal to 2. So again, y is equal to 3 to the 2nd, which is 9. Now to save some time, I've plotted the points. Now again, when we're looking at the y value of 1/9 or 1/3, it's really tiny if you look in there. We're somewhere between 0 and 1. We're definitely estimating. But also the idea is we're not going to cross that x-axis. The values, if we were to go to -3 or -4, they would get smaller or smaller, but they would never cross the x-axis. It would never get into the negative territory, or y would never equal to 0. So when I graph this, I'm going to start really close to the x-axis, but I'm not going to go over it. I'm not going to cross it. Again, with arrows on the end. And again, right here, that's that exponential jump that we talk about. As x increases at its normal units, y goes up very quickly. Now we can look at our domain and range. If I look at my x values, again, I can go anywhere. I can go to the right. I'm going to the left, says the arrow. So it's going to be all real numbers is my domain. And my range is all on the positive side. It's not touching 0 and it's not going negative. So it's going to be all positive real numbers. Our next function is y is equal to 1/2 to the x power. So we'll do the same thing. We'll use our table of values and we'll substitute them in. So I have y is equal to -2. So when I do that, I will have y is equal to 1/2 raised to the negative 2 power. So remember, I will raise my numerator and the denominator to that power. So I'm going to have to cross the dividing line. My exponent becomes positive. So in the end, I'm left with 4 over 1, which is 4. I'll do the same thing with negative 1. When x is equal to negative 1, I have y is equal to 1/2 raised to the negative 1 power. So I have y is equal to 1 to the negative 1 power over 2 to the negative 1 power. So that gives me 2 over 1, so y is equal to 2. If I have y is equal to 1/2 to the 0 power, that equals 1. Y is equal to the 1/2 raised to the 1 power. That gives me 1/2. And my last one, y is equal to 1/2 raised to the second power, gives me 1 to the second power over 2 to the second power, which is 1/4. Now again, to save some time, I applied the points, and again with the fractions, when y is a fraction, for instance, where it's x is 1 and x is 2, we have 1/2 and 1/4. I'm estimating. And when I connect my points, again, I'm not crossing the x-axis, and my domain here is going to, remember, I'm going left to right. My x values, I'm going to include everything, so I have all real numbers. My range, it looks like my range again is staying on above the x-axis, so they're going to be positive values. And I can always look at that. Looking at my table, I can figure that out as well. So I have all positive real numbers is my range. Our next function says y is equal to 2 times 3 to the x. So again, that x is only attached to that 3. So I'm going to substitute in my values. And I have y is equal to 2 times 3 to the negative 2 power. So if y is equal to 2 times that 3 is going to come to the other side, and that 2 is going to become a negative 2 is going to become a positive 2, so I'm left with 2/9. I'll do the same thing when x is equal to negative 1. So I have 2 times 3 to the negative 1 power, so that gives me 2 times 1 over 3. So that's 2/3. Now again, I have to be careful when x is equal to 0. So I have y is equal to 2 times 3 to the 0 power. Now remember, 3 to the 0 power is 1. So I'm going to take 2 times 1, so that value is going to be 2. When x is equal to positive 1, I'm going to say y is equal to 2 times 3 to the first. So y is equal to 2 times 3, which is 6. And then when x is equal to 2, I have y is equal to 2 times 3 squared. So that's 2 times 9. So y will equal 18. Now again, I've saved some time by just plotting the points. And again, notice this 2 to the 18, I just estimated. The idea is that we just know that that graph is going up very quickly. So again, I'm going to stay on the top of the x-axis, going to connect my points, arrows on the end. Now again, my domain is going to be all real numbers. I'm not excluding anything. I can have negative numbers, I can have positive numbers, which again I can see from my table. I always use negative 2 to positive 2, but I can go negative 10, I can go positive 10. My range is going to be, again, I'm above the x-axis, so that's all positive values. And if I also look at my table, now that we've done a few, I have all positive values there. So my range is going to be all positive real numbers. In our last example for today, we have y is equal to negative 3 to the x. Now this negative sign looks like we're going to have to be careful with that one. We haven't done one like that yet. So again, we're going to use our table, substitute our values in. So I have x is equal to negative 2, so y is equal to negative 3 to the negative 2 power. Now again, we have to be careful. This negative 2 is only attached to the 3. This is really like negative 1 times 3 to the negative 2. So that gives me negative 1 times 1 over 3 squared. So I have negative 1 over 9. So I'll put that in my table. Now when x is equal to negative 1, we have y is equal to negative 3 raised to the negative 1 power, which is negative 1 over 3 to the first, which gives you negative 1/3. Now again, I'm going to be careful when x is equal to 0. So I have negative 3 raised to the 0 power. So that's negative 1 times 1. So that gives me negative 1. And when I have x is equal to positive 1, I have y is equal to negative 3 to the first power. So that's going to be negative 3. And my last one, I have x is equal to positive 2. So I have y is equal to negative 3 raised to the second power. So again, this 2 was only attached to 3, so that gives me negative 9. Now I've plotted the points, and this one I just want you to take note of these values right here, negative 1/9 and negative 1/3. When you plot them, remember they have to go below the x-axis because they're negative numbers. So I'm going to do the same thing as I've done before. I'm going to connect all my points. And again, there's my exponential jump. This time it's going down very quickly. So my domain is still all real numbers. I haven't excluded everything. And this time, all my y values are below the x-axis, so they're all negative. And if I look at my table here, I have all negative values as well. So my range is going to be all negative real numbers.